topic is a real nice transition from this morning, and I know we've gotten a lot of questions related to gear and textiles and exposures of the gear. And so really excited to introduce Dr. Bryan Ormond, who this is his specialty. He's an associate professor at NC State University's Wilson College of Textiles, where he specializes in personal protective clothing and occupational exposures, in his joint appointment with the Textile Protection and Comfort Center. Since joining as a doctoral student in 2007, his research has focused on developing protective gear for first responders and military personnel, particularly in areas such as chemical particulate and thermal hazards. His recent work aims to reduce firefighter exposure to toxic chemicals through innovative PPE designs, decontamination methods, and evaluating the performance of respiratory protection for wildland firefighters in collaboration with global firefighting communities. Please welcome to the stage Dr. Bryan Ormond.
All righty. Well, thank you for the opportunity to be here. And just to clear up, I did finish these slides last night, so I wasn't working on them. I have a reputation that's probably true. But I'm happy to be here to talk a little, this area about textiles and exposures, PPE. There's a lot there. So when Natasha and Alberto asked if I would speak, I was looking at it and I was like, yeah, what do I include in that topic? And so what I wanted to kind of go is expand it, just look, over the past, 5-10 years, what we've been doing at NC State, but also just topics in general. You heard a lot about some of these things that I'll touch on already. And so when I think about the issue of cancer in the fire service, I kind of go back to where do we start? How do we deal with it? I remember sitting here, I think it was 2 years ago, and we were talking in one of the breakout sessions about all of the different, amazing, incredible work being done to catch cancer sooner. How do we diagnose it earlier? How do we treat people? All this other stuff. And I kept sitting there and thinking, that's after you're exposed. How do we turn off the exposure? How do we turn off that faucet of exposure? And PPE is one way to do that, just one of the ways. But that's where we can step in. So I'm at NC State. I'm at the Textile Protection and Comfort Center. We're in our 30th year of existence now as a nonprofit within the college. And our whole sole focus is protective clothing and equipment. And looking at PPE from the standpoint of, it's a study of trade-offs. What is it that you have to give up to get something else? And so that's where we have to try to balance everything. And so we need to understand the products of combustion, the types of fires, as you heard earlier about the wildland firefighting environment, fire investigators, structural firefighters, everyone else that's on the scene, all these different things. And so can we design the PPE better to mitigate these exposures? Looking at the respiratory protection, I'll touch on that. Looking at vapor and particulate protection for firefighters in different types of gear and different types of uses. And then there's a whole topic that I could probably spend 2 or 3 hours talking about, the manufacturing of gear, the PFAS chemicals and things like that. I'll touch on that at the end, just from the standpoint of what do we know so far. But I'm happy to answer any questions afterwards. I'll be here through the rest of the day about that topic. And we think about, not just the gear itself, but when we think about a hierarchy of controls where we have, administrative and engineering controls and other ways of reducing exposure, typically we stop at PPE. That's kind of the last line of defense. Well, when we think about firefighters, you also have what comes after that. You have the decontamination, whether it's on scene, the cleaning of gear, all these things that we have to look at. And so as Ron mentioned earlier, think mitigation, not elimination. We're never going to eliminate all of these hazards. But every single piece, every single tactic that you do, whether it's cleaning the gear, on-scene decon, washing your, using wipes, using, the charcoal soaps that are out there to help remove some of the smells, things like that. All of these different things add up, right? So it may be 1% here, 1% there, but that adds up definitely over a career. So think about that mitigation and the idea that was expressed earlier. You don't have to be perfect, right? Do it today, do it tomorrow, keep showing up. So I want to look a little first in kind of routes of exposure in terms of what we're looking at for PPE. The first being mitigating those inhalation exposures. So one of the things that I would hope you would leave with from this is just understanding that is one of your primary routes that you need to worry about protecting. Whether you are a structural firefighter going into the structure, if you are a pump operator sitting by the engine, incident command, the paramedics, as you've already seen multiple times today, everybody on that scene can be exposed. Many of those are going to be inhalation exposures. Are you actually wearing SCBA the whole time? Do you have other types of respiratory protection on scene that you could use as well? And so there's been a number of studies. I'll just highlight this one from University of Arizona with Tucson Fire from Jeff Burgess out there at Arizona. But looking at just the PAH exposure in firefighters pre their baseline levels, and then comparing back to post-fire. And you see the engineers down there had really high levels, some of them. What came from this is they went to see if you put them on air, does it impact it, and severely or significantly drop their exposure levels. They were just in the smoke cloud, not wearing anything, right? And so these are just different types of exposures, but we're trying to mitigate that exposure on the scene with respiratory protection of some sort. How do we do that when we get to something like wildland firefighters, who, as you heard earlier, have no requirement for respiratory protection, have no products that have ever been certified? I'll go a step further, and there's never been a product submitted for certification to the NFPA 1984 standard, to my knowledge. And why is that? There's no market, believed to be no market, because there's no product, and there's no product because there's no market. So we have to figure out, wildland firefighters are not a normal occupational setting, right? So all respiratory protection in the U.S. is governed and regulated by NIOSH, right? The O stands for occupational. And so one of the things that we decided to do, we've been working towards this area for a long time. I think COVID actually helped a little bit because we started using our head forms, as you can see here, animatronic head forms, to start looking at face coverings. How effective are these cloth or barrier face coverings compared to, say, an N95 or something like that? And so one of the things when we go outside of the occupational setting that you have control over and you get to the wildfire setting, it's not standard. Right? You're not going to have clean shaven. You're not going to have, can take it, wear a respirator for a little bit of time, then take it off and do everything in a great scenario. And so you're also, the wildland firefighters have significant physiological burdens just in general, right? So if we're looking at this and saying user acceptability is paramount, we can have a product that blocks particulates, that's easy to breathe through, but if they're not going to wear it, not going to use it, then it doesn't matter. This is the exact same things that we went through as we started looking at, like I said, face coverings during COVID. And so what we try to do is look at this on a holistic level. We started looking at it not just on flat pieces of material, not on things, so when you do an N95 test, NIOSH is the Code of Federal Regulations, that is a perfectly sealed system. It is an N95 that's put down, it's sealed with beeswax or hot glue, and you're really doing a material level test. Well, we don't seal those things, thankfully, to your face. And so we have to pay attention to how things fit. And so what could be possibly used for wildland firefighters? This is a list, images here, of everything that we have tested so far on our head form. The ones at the bottom that are grayed out, those we just haven't finished the data for. But we've tested all these different things, starting from your PAPRs. You have full face, half face, powered air purifying respirators. We've looked at your standard half face APRs or air purifying respirators, quarter face, full, half, and quarter face. Then moving to your N95s, things like that would include your filtering face piece respirators, right? So that's really your respiratory protection on the left side. You go to the right side, now we get to those alternative type products, things that are absolutely targeted to wildland firefighters from a marketing perspective right now. But we have bandanas. That's their state of the art technically. I can tell you from experience, working with these materials, bandanas are not really helping much at all. But we're looking at them because we have to put the bookends, right? We need to look at the entire spectrum of performance. Neck gaiters, hoods. We have wildland firefighter hoods that are targeted that just have a knit, a pretty open knit structure over the front, right? You always have to worry not just about performance here. You also have to worry about the potential of embers, other types of flammability hazards, things coming up. And so that's why many of these materials that you see are actually, they're black fabric, they're carbon-based fabrics. But then we have other types of barrier face coverings that, actually some of these started to be developed during COVID, some of the manufacturers. So we're trying to look at all of them and see what can we tell, what's possible. And so when we do things in the lab, what you can see in this graph, the y-axis is looking at total filtration efficiency. So if we had an N95, it should be 95 or above. So you're looking for that top left corner. But you can't just look at protection. You have to look at the comfort, the usability. So that bottom graph is the inhalation breathing resistance. And so if something is really difficult to breathe through, if it's down where the picture is down here, you're not going to wear it. You're not going to be able to breathe through it. During COVID, we saw people advertise 99% filtration efficiency with a membrane. So that's great. I can also put a plastic bag on my head. Like that's not filtration. That is just blocking things. And it's dangerous if you're thinking about someone trying to breathe through that. And so what you can see is this kind of clustering up at the top of your respiratory protection. Your powered air purifying respirators have lower breathing resistance because they're actually supplying that, pushing that air into the face. But we also have many of the APRs which are down further. They're harder to breathe through. That's why people don't like wearing N95s. And that's just when we're just sitting around, in a classroom or, in a hospital or something like that. Not when you're cutting, laying hoses, using chainsaws, that kind of stuff. So what's feasible? Ideally, we want to find something that's in that top left quadrant. But we do have some other products that are that 50, 60% that we could potentially have people use. And as was said before, I've gone back and forth with this, not just for wildland firefighters, but also for people in areas impacted by wildland fire. We're not coming down from 95%. That 95% is what NIOSH says is respiratory protection. We're coming up from 0 for most people. And so the idea of not giving them something just for the sake of meeting that 95, I mean, sure, it's going to take education and making sure people understand the limitations, but the alternative is not doing anything. And so one of the things that we went out of the lab, we try to get in the field as well, so we're looking at field sampling. You can see in the red circle there, this was actually a trial that we ran on fire investigator exposure. So we set out 3 shipping containers, we filled them out, room and contents, and we were doing post-fire stuff, and I'll show you some of that data later. But we still had to burn the thing, and so we were like, well, let's take advantage of this. Let's try to put the head forms out there. So we actually had cascade particle impactors. We had some sorbent tubes in there. It's really difficult to chase the smoke cloud that's coming out, so we didn't quite get the same exposure every time. But one of the things I wanted to point out, and it's kind of difficult to see, but the little circles that you see there are the individual filters that would have different size particles on them that got through. So the head form that had nothing on it, you can see these little lines coming across. Right? Those are particles from the smoke that went into the mouth and got detected on the particle impactors. With the bandana, there's basically no difference. You can see, if you get close enough, you can see both of the lines on the same thing. The N95, you start to lose any lines on the first, I think, 2 to 3 of those. And that's because those are the smallest particles. It's actually filtering those out really effectively. The N95 was their standard kind of cup size, and it just doesn't always fit well for a certain head form. The idea was to look at this and say, things that are visual, people can respond to. Right? It's one thing to just say, hey, this is 95 or 90 or 60, but you can literally see the particulates that are actually coming through that bandana. And I imagine, being able to take this to, say, a cardiologist, pulmonary cardiologist or something like that, and saying, over a career, would 50% impact that person's health? A 50% protection or 50% reduction. And it's something that we have to continue to look at and see what can we possibly do. Moving on to the dermal part of this, I've done a fair amount of dermal absorption work in conjunction with the NC State Veterinary Medicine School. And what I've learned over that time is dermal absorption is much less about can something go through the skin and much more about how fast and how much. Given enough time, you can just about have anything that permeates through. And so what we're actually doing is a couple different ways. One of the ways we do this is called in vitro testing. That's where we actually take pig skin, we cut out a small piece, thin it out to a consistent thickness, and we put it in a test cell. In that test cell, what we're trying to do is basically, I didn't realize we were doing this originally, but as the projects build up, we started building this Firefighter dermal exposure database. So we started testing things the exact same way. So that now, I'll show you, we have 3 PAHs, the naphthalene, phenanthrene, and benzoate pyrene that we've worked with. We have 3 PFAS compounds, PFBA, PFHXA, and PFOA. We also have a couple other ones that we've moved into, controls, things that we can compare back to, things that we know go through the skin. But when I say we're doing it in the same type of situation, same type of system, we're using a consistent dosing vehicle, sweat, artificial sweat. Right? You can use acetone, methanol, all these other things. But we want to try to be as realistic to firefighters as we could. We also go to 37 degrees C. There's studies out of the Illinois Fire Service Institute that look to see that's about the temperature that your skin's going to get in a normal fire response. We've also done changes in those temperatures, looked at 5 degrees decrease in temperature, see what that does, a 3 to 5 degrees increase. And we're also doing kind of a worst case. We're doing 8 hours and monitoring that whole time period. So what do we get? When we compare these, I'm just showing you naphthalene data right now, but the phenanthrine's a little bit lower. Benzoate pyrene was almost, we didn't detect much of anything in the body, or in the perfusate, what we call it. But if you just look on the left side, those are things that are coming off of every fire. You saw that earlier with the lithium-ion battery work. Naphthalene is coming off just about everything that burns. You're getting high levels of naphthalene. If you look at the scale of those two graphs on the left and right, there's a significant order of magnitude difference, a 50% versus a 0.5%. So the fireground combustion product, naphthalene, 35% of what we applied on the skin went into the skin and was detected. When we started testing the PFAS compounds, PFBA was the highest, and it was 0.0 or 0.2%. PFOA got down to 0.05%. And so, a lot of times when we talk about the PFAS stuff, I get people to ask me, like, do you ever have good news? And I was like, well, technically hopefully this is. The PFOA, the PFHXA, the PFBA, we've done this numerous times, and we don't get a lot of absorption. I know there's other studies, and we've done some as well, where we used skin analogs, not actual, live tissue. And many of the analogs, I think it's EpiSkin is one. We use Strat-M. Those, they're similar, but PFAS compounds fly straight through those. On the other side of that, when we've tested the more hydrophobic compounds like naphthalene and things like that, they're less absorbent, or allow less absorption than skin does. And so there's a lot more that needs to be done with understanding this question and filling the data gap. Because right now, we don't know what level of exposure you actually get from putting on PPE that has been treated with PFAS. There is no data that has been collected that I'm aware of, and I'll be happy to look at anything anybody has. But we're trying to do that. We're trying to fill that gap, because that's a pretty important question when it comes to what's our exposure. Right? What is the exposure from putting this gear on? And many times it's on the outer shell. So it gets even more complicated, because you're not really wearing the outer shell next to the skin all the time. We know those chemicals are absolutely there, and we'll talk a little bit more about the transition in a moment. But where are we going? So PFAS can take a really long time to get into the skin. I showed you earlier we did 8 hours. It can take longer than that to show up. And so we can't go much past 8 hours with the pig skin, because it's just not viable after that time. And so we're moving to in vivo studies, meaning we're going to live pigs. We just met on Tuesday about this. This will be taking place, the first trial, will be taking place in July of this year. And basically, we are going to use what we call hilltop chambers. They're little chambers that we put on the backs of the animal. You can put the exposure, dosing liquid, whatever it is, and you leave it there. We're going to leave it there for, I believe, 4 to 8 hours. We got to decide exactly what we're going to do. But the goal is to look at PFOA, PFHXA, PFBA, and then the sulfonated versions of those. As you saw before, like in the soil samples, those sulfonated ones show up quite a lot. Typically are attributed with, or thought to be because of the fluorinated foams that are used. But those are not the products that you can extract directly from the fabrics normally. They're kind of the terminal products, the things that can break down and they stay in your body that way. We're going to also have one pig that we look at with 6,2-fluorotelmer alcohol. That is the side chain finish. When it comes off, when it breaks off, that's the compound that would be on the skin. And so what we're going to do is to look and see if we expose this animal. We don't just measure blood and urine. We're going to be able to get tissue samples. If we didn't detect it in blood or urine, where did it go? If it got in, is it in the liver? Is it in the kidneys? Is it in the fat cells? On down the list. When I told the people at the vet school we wanted to do this, they just kept naming off different tissues that they wanted to measure. They're very excited about it. But so this is all through NIST funding, so federal funding from that side of things. And so it's something we've been planning and gearing towards for a while, but hopefully we can finally fill some of that data, the gap that's there, and try to understand what type of exposure are you potentially getting just coming in contact with these chemicals. The next piece of that is to essentially put pigs in semi-turnout jackets and simulate that and see if we put the treated fabric in direct contact with the skin, simulating a 2-week shift for a firefighter and monitoring for 2 additional weeks. Do we measure anything coming through? And so that's where we're headed on the exposure piece. But when we think about how do we limit that exposure, how do we stop some of that, we think about the vapors, the particulates. So we've had dermal protective protective clothing or particulate protective garments that have been made. One of those in particular was particulate blocking hoods, which are going to now be required for all structural firefighters by the new version of the NFPA 1970 standard. We've worked on and developed and have been seen commercialized smoke-resistant turnout ensembles. And so you can kind of see it's been sort of hard to follow because things have changed so fast in the hoods. But there's this idea of, you can see in the pictures, that green that's lit up, that's the particulate that would be kind of worst case if you don't put anything on. And then a traditional 2-layer knit hood, just like we're talking about with respiratory protection, the filtration, having something there does help. Those are about a order of magnitude decrease. And then when you go to a particulate blocking hood, you can't really even see the head form there because there was really nothing there to light up. And so that's another order of magnitude protection. So just to show you how these tests are done, this test is done at RTI International in the Research Triangle Park in North Carolina. And so basically you put them in an environment where it has these fluorescent or phosphorescent aerosols, and they just do exercises. This is from some of the early DHS work that we did developing the particulate blocking ensemble. And really what you do is you look at pre-exposure and post-exposure, and you can see those areas that are highlighted with the yellow. Those are where infiltration occurred, right? So turnout, it has a moisture barrier, so you're not really going through the material. This is all about the interfaces, what's coming up the wrists, the waist, and you can see that deposition in the post-exposure. When we went to the design, the product that we developed with this, what you can see is we did testing and we didn't see anything else on the body. So we know technically it worked the first time we tested it. Then we spent another 12 months reiterating and revising the design so that firefighters could actually wear it and not have to change what they were doing. You couldn't stage your gear the same way, so we had to change that. I had a firefighter tell me very, very bluntly he was never going to button the buttons, so we had to make the zipper longer, so that's something we didn't have to do. So it's one thing to be a technical success, specifically with PPE. It's another to have something that people are actually going to use, and that's the most important part when we get down to it. So that's the particulate side. We also have at NC State I think it's the only facility to do what's called man and simulant testing or vapor protection testing. The only one at an academic institution in the U.S. and possibly in this hemisphere. I'm not sure if there's any at any academic institutions in the world. I know there's a couple that are at military bases and things like that. But this is what I've spent the better part of 15 years working on this test, doing hazmat suit certification testing, military work. And so what it is basically we put someone in a chamber. We put these passive samplers, which we're also working on developing new ones for that, based off the silicone stuff that you saw earlier. And so what we can get is a measure of what gets in across the body. So typically if you do a study out in the field, you may see 1, 2 data points inside the garment or on the person. You get biological samples as well. What we're actually doing is putting 36 samplers across the person's body. We get really detailed information so we can tell where did it come in. Did it come in the waist? Did it come in through the collar? And so we took this through some FEMA funding. We looked at fire investigators. It's something that Jeff Pauley came down and talked to me one day, and we decided, hey, you don't have to take scraps from other projects. Fire investigators need a whole effort to themselves, and this has been a long time in the process. We're still working on data for it, but you can see we took 10 different ensembles, things that fire investigators may wear, from a base layer, disposable coveralls, reusable coveralls. We had things with particulate blocking layers that we added in, a standard structural ensemble, a particulate blocking structural ensemble, a coverall of that to get rid of the waist interface. And then from my background working with Chem Bio suits, we also threw in a carbon absorbent flight suit because I know how effective those can be at stopping vapors. And so just a summary of what this data can look like, we get a systemic protection factor. So all 36 of those samplers added up across the body and look at a protection factor. So the lower number that you have, so if you look at the bottom one, the base layer, that's just a shirt and pants that is actually what ATF wears when they respond. That's a rough, about a 2, right? So typical clothing, 1 is the lowest number you can get. That's full exposure, so you're basically not wearing anything. So 2 is not really that much better. When you look at the disposable coveralls, we get a slight elevation. They're also, the coveralls had hoods that covered the head and neck, which are also vulnerable areas. We go to the reusable coveralls, kind of tech rescue, wildland type garments. It dropped down again because there was no protection on the head and neck. They didn't have hoods or anything like that. When we went to the particulate blocking 2-piece, you see this increase in that dark purple color. And that's because we went to having a barrier in there. So it's no longer coming through, just straight through the knits or the woven material. It's having to come around. When we go to the structural system, The structural suit is not vapor protective. It's not intended to be, it's never designed to be. And so it only provides about a protection factor of about 8 to 10. Well, it's surprising in some ways when we went to the particulate blocking suits. You look at those, they're almost over twice the vapor protection. They're not intended to block vapors, but we're also shutting down some of those interfaces. And this is one of the reasons that people report, hey, I don't smell like smoke when I wear this. It's because it's stopping the particles and some of the vapors from getting to your skin, so it's helping there. Now, the one that I'll point out that I expected to be much better was the flight suit. You see, that's only about a 10, very similar to the structural suit. The problem was it has no head covering whatsoever either. And so when we take that out, you can see a significant increase to about 70 protection factor. So another way of looking at this, to show you the level of detail that we can get across the body, this is just the total mass for each individual location. I mean, you look across there, you can see there's some gaps because we test the feet, the hands, and underneath the respirator. So those are very well protected. So those are the ones that you see kind of gaps there. But the longer that bar is, the more mass was detected across the body. And so when we have the base layer, it's 40,000 nanograms on every single sampler we measured. When we start to move across and you go down to the next one, you can start to see the impact of the protective clothing. If you look to the far right, that's the flight suit. Like I said, we know exactly where that exposure was happening because it was the head and the neck. Everything in that area, there was no protection there. But you look across the rest of the body, and there's a significant decrease and shows promise. I don't have time to talk about the next step that we went through. About a year ago, we did field studies where I showed you the picture earlier, but we went out and we've collected biological samples. We've done this test in the field with silicone samplers, and it actually is correlating, what we know so far is correlating fairly well. The important part of that is it's a whole lot easier for me to test in our environmental chamber than it is to burn a structure. And so we have a much more control over that, and that's hopefully where we're going. With the last little bit that I have, I want to talk about the transition and navigating the transition to non-PFAS PPE. I've been following this for 8 years. I feel like I talk about it every single day. My wife and my students are probably done hearing about it. But it's this issue that if you don't take anything else away from this, understand that it is complicated. The more I've looked at it, whether it's the gear, the foams, we've done work with the North Carolina Fire Marshal's Office on non-fluorine foam training and things like that. It's complicated. These things were used for a purpose, and there's not a whole lot of things that we can go to that provide that same level. And so, like I said at the beginning, PPE is always the study of trade-offs. And I can tell you right now that there absolutely are alternatives to PFAS that can be used in the gear, that are being used in the gear now and in foams. They're not direct replacements for what was there. I think that's one of the things that we have to understand is this gear will be different. The problem is when we go through that balance, we don't necessarily always know how big that difference is going to be. And there's stuff in the field right now that people may not realize they're wearing non-PFAS gear. If your gear was manufactured after 2021, 2022, all the outer shells in the U.S. no longer have PFAS as a treatment. And there's a lot of people that don't know that. And that's something that, as you'll see when we go through, is really important. Right? So the state of this transition, basically what's happening for the outer shell materials, these have been water and oil repellent finishes, both water and oil. If you can repel oil, you can repel water, but not the other way around. And so basically the finishes have switched from fluorinated carbons to hydrocarbons. Well, the problem with that is you're also, as firefighters, potentially exposed to hydrocarbon fuels that are flammable. And I get the question of, does this happen? Is this something we have to worry about in the field? This was from a year ago in New Jersey. I contacted and talked with people that knew what happened here. But what you can see is the firefighter is using a circular saw to cut open the garage door. This is PFAS treated gear. I don't know how many years old it was. But essentially what happened is the gas cap was loose. So check your gas caps, make sure they're sealed. He lifted it up, it spilled down the front of him, and then all it took was a spark to get the gasoline to light. Now this is probably a best case scenario because he was outside, got down pretty quickly, and they put it out. But you can see the whole kind of waste is on fire there. But one of the things that I'm concerned about with the data that we've been looking at, and this is all through FEMA funding again, is that like I said before, we're replacing with hydrocarbon finishes. If you have hydrocarbon fuels and hydrocarbon finishes, you've just created a wicking finish for diesel fuel. Just to show you what that looks like, this is some treated gear. The PFAS treated is Legacy. This is a horizontal wicking test that you can put a milliliter of diesel fuel on there. And you can see this is as new, right off the roll, or if it was a jacket, it'd be right after you got it. We know that PFAS treated gear can wear down over time, but this is a difference. It is a change that firefighters need to know about and need to be told about when they're issued that gear. Is if you are near a diesel fuel or any other type of flammable fuel fire, pay attention. Know that you don't need to be around open flame if you've been exposed at any amount. This is only a milliliter. This testing, the next testing I'll show you, this is the alternative non-PFAS treatments. You can see you can get great water repellency, but the diesel fuel, the hydraulic fluid, not as much. And it's not just enough to say, is it just a flammable fuel or not? Gasoline is different than diesel, is different than hydraulic fluid. You can see the hydraulic fluid, the viscosity, the thickness, it doesn't spread nearly as much. That diesel fuel spreads out considerably. And so when we have a much larger surface area that's covered, the question comes, well, if we do have that flammability hazard, and just to say, absolutely, if you can get back to the station, wash the gear, you hopefully shouldn't have a problem. But the problem comes when you're actually responding to that same incident like you saw in the video, and could we have problems there? And so we're starting to ask the questions of what type of flammability exposure could you have? This is a flash fire cylinder test. You can see we do a 4-second flash. On the left is the non-PFAS composite where no chemical was added. So this is normally how things would be tested if they did this test in the standard. On the right is after we've exposed it just to 10 milliliters of diesel fuel. The nice thing about this test is we can also collect heat flux data underneath the fabric. Every sensor that was underneath that diesel fuel splash recorded some degree of burn injury. This was the first time we did this test. We're going back, we're doing more. I had students that got back on Tuesday because the snow was coming to Raleigh on Wednesday. And so they were doing this testing. So we're going through. We're trying to finish this project by May. We'll be presenting a lot of it in March at the Fiero PPE Symposium in Greenville, South Carolina. There's a lot to this. There's a lot of nuance, and it really should not be simplified. We really need to ask these questions. Now, that's just the outer shell, and I'm running, I have 2 more slides. But the moisture barriers are another thing. The outer shells transitioned really quickly. They didn't make new finishes, didn't make new materials. They just switched to things that were already used in outdoor jackets, other water repellent finishes, things like that. But when we start removing the moisture barrier, the PTFE, the polymer version that's in the moisture barrier, it's going to be replaced with things like polyurethane, things like polyester or some sort of combination thereof. And so we don't know now how they're going to perform in the field. Just to give you an idea, these are some samples. The one in the middle sort of is a PTFE barrier that we put through a aging process. Hopefully you can kind of make out, there's a wrinkling that appears on the surface of that one, the one that's more white. So that's common with a polyurethane. So most moisture barriers are PTFE and polyurethane together. Polyurethane is susceptible to water. It's going to soak in, so you get that wrinkling. It's more exaggerated on the bottom picture. That is actually a picture from a set of gear that has the current non-PFAS barrier in it. It's been used for about 7 or 8 months now in the field here in Florida. And so you can kind of see what the damage could, or not necessarily damage, but the difference looks like. I have no idea how well that still performs. And so when we start transitioning these barriers, the yellow one up there is something to think about. The wrinkling, the yellowing, those are indications that things are happening to the materials. And firefighters, as a daily thing or a weekly thing, there's an inspection port. Flip it inside out and look at it. Look to see if it's yellowing. Look to see if it's wrinkling up, because we really don't know how these are going to perform 1 year in the field, 2 years, 3 years, because they just went into the field as people have started making them. Now, there's a lot of changes that are happening in the NFPA 1970 that was just issued in, I think, August, somewhere around there. And so they're going through and certifying things now. There's restricted substances list now that things have to pass. I don't believe any of the current non-PFAS barrier will pass that test because it had significant levels of brominated flame retardant on it that we measured with Dr. Stapleton at Duke, and that's a restricted substances now. And so that has to be reformulated. I know at least one of the barriers that's on the market is probably in its 5th formulation at this point. So things are changing. There are other ones coming on the market, but now we also have to look and see not just the durability, but the impact on heat stress. That's the place that we're going next, is trying to understand what is the impact, because polyurethane barriers do not breathe the same typically as PTFE. That's one of the reasons the PTFE barriers were used, is because they allow moisture to move through in a vapor, get rid of the humidity, get rid of the heat stress. And so we need firefighters to pay attention to symptoms of heat stress when you switch to this gear as well, until we have a better idea of how it actually performs in the field. But that regular inspection is going to be critical. So key takeaways as I finish up, one of the things, if you want any information about any of the things we're doing, my students have done a great job finally putting our website together. So it's got a lot of information on there. But like I said before, focus on mitigation instead of elimination. Try to cut down as much as possible, and you don't have to be perfect every day. Use PPE appropriately, but also use appropriate PPE for every situation. Whether you are an incident commander, you're a fire investigator, structural firefighter, a paramedic that's on scene. These are all types of exposures and jobs that you're going to get exposures if you're on scene. And so we really need to pay attention to that. If you can protect your respiratory tract, that's going to do a significant impact. That is not just on the scene, that is in the station. If you're dealing with PPE, if you're doing cleaning, I mean, the ISPs, same thing. You can wear respiratory protection while you're handling these things. And then the idea that navigating the transition to non-PFAS PPE, like I said before, there are alternatives. They are not direct replacements. Things will be different. It's okay that they're different. We just have to acknowledge it and work with it. And lastly, I'll leave you that every firefighter must be trained on the differences in this gear before they ever are issued the gear, before they ever use the gear in emergency response. Because if they're not acclimated to it, they haven't been trained on it, that's when things can happen. We know this has already happened in some instances, not just with PFAS, but with the particulate blocking hoods. Big changes that have happened in the gear can cause big problems if people are not trained and acclimated to it. So, like I said before, if new gear is fielded, inspect it, keep records. Records help us as researchers to be able to understand what did your gear go through. People send us sets of gear all the time. We never really know what it went through, how many washes, when was it issued, all that kind of stuff. And lastly, with the reevaluate your expectations. The chemistry it doesn't have the answer to everything. We may not be able to achieve the same level of performance without the PFAS finishes that we did with it. And so you may have to rethink what you think that gear is supposed to achieve. What performance are you looking for with it? And that may be rethinking work cycles, adding another person, whatever it is to help with those rehab procedures and things like that. And so lastly, I just want to acknowledge the funding. I've highlighted FEMA there because, as been said before, federal assistance for these, the FEMA grants drive a lot of this, a significant amount. And those are under fire now as well. And so just think about that. If you have anyone that you can call and talk about, that'd be great, because there's so much good work that comes from the FEMA grants. It's important and critical to keep those so that we continue making sure that firefighters are as safe as possible. Thank you. Any questions? Yeah.
Hello? Okay.
There you go.
They have not found at 3M in their own workers that they've studied with their own studies long-term mortality effects and cancer in their own workers, which I would assume have the highest exposure level to these compounds. However, these are studies sponsored by 3M, conducted by their scientists, but I believe that they're acting with integrity. So what do you think about the risk versus benefits of using what you've shown are effective forms of PPE and have some of the that don't have some of the problems that the newer alternatives have? And how would you advise firefighters in light of what we don't know about PFAS in terms of long-term effects? Because we have a lot of animal data, but mostly just epidemiological human data.
Yeah, and I think the PFOA itself, as the one you mentioned, is a known carcinogen now. One of the researchers at NC State, Dr. Jane Hoppin, was on that committee, and I've talked to her about it. And a lot of it was mechanistic data, I think mostly. And so the epidemiological studies are missing from some of that. But the fact is, it's still a health hazard. I don't think anybody should be saying that these things do not cause health implications or health complications and things, specifically cancers as well. And so a lot of it gets down, the problem with these chemicals is they're used everywhere. They were used in way too many places. Things from carpeting to cosmetics to on down the list. Any product you can think of probably has it in there in one way or another. And so, I kind of look at it like I said, we have to reevaluate what the fire service needs out of their gear. And it may be that every firefighter may not need this, but there may be some that are. And that's a really hard thing to figure out, specifically when it comes to the barriers, because you're not really touching those all the time. And that's why we're trying to understand the exposure piece, because if we can balance the exposure piece and know what comes off and what gets into a person with the performance, then you can start to do your risk assessment. Because right now it's been just assumed the chemicals are there. They're absolutely health problems and bad. They should be removed if at all possible. But we don't know the exposure piece. And so I think the science is still catching up. There's a lot of people in this room, as well as the fire service community, that are looking at those things. And I think the more studies that are done, hopefully we find whatever we find from the pig study, that'll go to that body of knowledge. And so it's not just, not just one group at 3M or somebody else. And I know that's one of the reasons we've tried to stick with federal funding with all of this, is to try to avoid any kind of conflicts of interest from manufacturers or anything like that. And so it's been difficult in many ways. And this, like I said before, the topic is complicated, but we can't not do something just because we don't know. Yes.
Hi, good afternoon. Our current specification is a wax-based PFA-free finish, and we were participating in a trial testing some PFA-free moisture barriers. Some of the feedback, unfortunately, was our outer shell gets soaked with water and tends to weigh us down, in addition to the discomfort on the inside because of the moisture barrier difference. So we use a wax-based finish now for our outer shell material. Have you seen any difference in the different new technologies as far as durability and water repellency?
So we're hoping to finish, we have samples that we've put through a ton of different aging processes. And so we have new samples, new and aged, that went through contamination burns at Illinois Fire Service Institute. So that's what we're hoping to finish by May, because in that we're looking at laundering, heat exposures, and UV exposures. And so we're trying to understand exactly that. What is the durability of performance? So in terms of water and oil repellency, those were the tests that they actually just did last week or this week. I do know that the non-PFAS, the wax finishes, we can't replicate it in the field or in the lab right now, but from the field we have heard that those materials break down or are breaking down faster, and you have to have more repairs or they have to be replaced sooner. I don't necessarily have a good answer for that, but I think what's happening is, if you imagine Teflon is used, as a non-stick surface. That's essentially what you're putting on these fabrics. So if you coat every fiber with a non-stick surface, they sort of slide past one another, sort of like a lubricated in some ways. And so that's a very durable, thermal exposure is very durable, and so you're not getting an abrasion there. When you switch to the wax finishes, I think what's happening is they're not as thermally stable, and they start to break down earlier, and you get fiber on fiber rubbing, which you get some of that abrasion happening, a thinning of the materials. A lot of that's anecdotal information, and that's where we're trying to go, is to further look at some of the durability work, because most of the testing that's done by the NFPA, there's no aging of the materials. It's very minimal in some instances, but we don't really look at things 2-3 years down the road. And we really need to do that. It's difficult to do. That's the excuse that I've been given is why it's not in the standard, because it's difficult and expensive. And I said, that's exactly that, isn't an excuse. We still need to do that and need to understand how they perform.
And separately from that, along the same line, with the PFA-free treatments, are they more prone to holding on to deposited products of combustion? Because anecdotally, especially with our training classes, so Class A materials, nothing crazy, it's just hay and pallets. It takes 2 to 3 washes in order to remove smoke smell, and which is further degrading the gear, further removing the repellency and all of that.
It's possible. So if you step outside of firefighting, go to PFAS finishes that have been used in outdoor apparel, anything that's oil resistant, things like that, upholstery. It is known that if you get those contaminated It's sort of the oil sits below the flooring finish, and it's hard to get it out. So it's possible. We should be able to answer some of that with our data because we did do washes on samples after they had contamination. We're supposed to do some measurements of that, but it is just from a using of a fluorinated finish on any type of product. If you can contaminate it and get it past the finish, then it is more difficult to remove than normal.
Thank you.
Yeah.
Your particulate hood that's dual layered, can it be extended to cover like the full body?
It could, and that's to some ways some of the particulate blocking suits. So even some of the things that Matt showed earlier with the wildland gear, it's a PTFE barrier. Almost all of the particulate blocking hoods are a PTFE barrier, except for the one technology. But that same barrier being put into, say, the not a structural suit because it already has a barrier, but like any of the other types of wildland tech rescue, it could be. And so it's a matter of balancing what level of heat stress is that going to add, because we do have measurements on that. I've tested all of those suits as well on our sweating mannequin system that gives us a measure of heat stress. And you can definitely tell a difference. When you put a barrier, you start to have increased heat stress. And so that would be the balance. All right, good. Thank you.